Okay, this is the P3 paper from January 2024. It's question number 7, and this is a mixture of topics. We've got a little bit of work on differentiation. We've got finding the equation of a normal, but then after that, we've also got some integration. So let's jump in and have a look at what they're asking us to do. They're telling us we've got this curve given by this equation here, and it says, can we find dy by dx in its simplest form in terms of k? So yeah, we can jump in and do that straight away, then we'll read the rest of the question. So part A says we've got y equals 16 over 9 3x minus k. So I'm just going to rewrite that before I try and differentiate it. I'm going to take the 16 over 9 out and just say this is 3x minus k to the minus 1. So now we know how to differentiate this. Early on, you'd have used the chain rule and taken a little bit of time, but I think by the time you get to the exam, we should be able to say, right, what's dy by dx going to be for this? The 16 over 9 I don't need to worry about, that's just a constant. But then what I've got here is something to the power of minus 1. How do I differentiate something to the power of minus 1? I multiply by the power, which is minus, take 1 off the power, which becomes k to the minus 2, but then the chain rule part would be multiplied by the differential of what's in there, and the differential of what's in there is multiplied by 3. At the stage of doing the exams, guys, you should be able to do that pretty quickly without too many issues. So tidying that up is minus 16 over 3, 3x minus k. You can either leave it as to the minus 2, or you could put it as back over 3x minus k all squared, doesn't matter. Okay, but that's part A done. Then part B says the point P with the x coordinate 1 lies on C. Okay, given that the gradient of the curve at P is minus 12, can we find the two possible values of k? So what they're saying is that when x equals 1, dy by dx equals minus 12. Well, I can sub that straight in, so it's not too complicated for part B to be able to just follow through what we've just said and say, well, at x equals 1, dy by dx is equal to minus 12, so I can put that into what I just found. Dy by dx minus 12 is equal to minus 16 over 3, 3x minus k squared, well, that's 3 minus k to the minus 2 now, so I just need to be able to try and solve this equation. So if I'm trying to solve that, we'll get rid of the minuses first of all, and then I'm going to take the 3 to the other side. I'm going to say 36 is equal to 16, but then also this 3 minus k is written down like that. All I've done there is multiply that by that one and get rid of the negatives at the moment. Okay, let's take the 3 minus k over to the other side then as well. So I've got 36, 3 minus k squared is equal to 16. Let's cancel out the 4s from both of them. This is 9. Lots of 3 minus k squared is equal to 4. I'm going to do that before I start multiplying everything out. I want to have slightly easier numbers to work with. 3 minus k all squared. You take your time to do it. I can do that quite quickly. That's k squared minus 6k plus 9 equals 4. Tidied that all up, so that's what's that? 9k squared minus 54k, and it's plus 81 but minus the 4. Let's do that all in one go. So that's plus 77 equals 0. So now we're going to try and solve this equation. I've got other videos that show you how to factorize a quadratic where a is greater than 1, so go and have a look at those. I'm not going to spend any time doing that, guys. The video is going to be too long otherwise. So this factorizes out to 3k minus 7, 3k minus 11, which will give me k equals 7 over 3 or k equals 11 over 3 as my two values for k. Okay, so let's go back. Yeah, so we've done part B. Given also that k is greater than 3, well, if k is greater than 3, then it has to be 7 over 3, because, k is less than 3. Then it has to be 7 over 3, because 11 over 3 is bigger than 3. So there, by that statement is telling me k is equal to 7 over 3 then. Okay, what else are they telling me? They're saying find the equation of the normal to C, write your answer in this format. So don't remember to come back and do that. Don't forget to come back and do that at the end. But what they're asking me for is the equation of a normal. If I want the equation of a normal, I need y minus y1 equals m, x minus x1. Do I have y1, x1, and m? Well, I nearly have m, because if I know that the gradient of the tangent is minus 12 here, I can sort out what the gradient of the normal is going to be. It's going to be 1 over 12, but we'll show that working in a minute. I have x. x1 is going to be equal to 1, but what I don't have is y1. So y1 is going to be the first thing that I'm going to try and do here, and then I should be able to sub everything and sort it out. So let's tell the examiner what I'm going to be doing here. So I'm going to say, it's up to you which way round you do this now. So first thing I'm going to say is that k equals 7 over 3, because we've been told that. And what I'm going to do is to work out the gradient of the normal. So I'm going to say gradient equals minus 12, gradient of the normal is minus 1 over that, minus 1 over minus 12, so that's 1 over 12. We need y1, and I've got that y is equal to 16 over 9 3x minus k, but I know what x is equal to 1, and I know what k is equal to 7 over 3, x equals 1, k equals 7 over 3. So if I put all that in, y works out to be 16 over 9, 3 minus 7 over 3, and what does that work out to be? That apparently works out to be equal to 8 over 3. So now if I want to work out the equation of my normal, equation of any straight line, the equation of the normal is given by y minus y1 equals m x minus x1. What have I got? I've got x1 was 1, I've got y1 is this 8 over 3 I've just found, and I've got m equals 1 over 12 there. So I've now got everything to be able to put in there. So what have we got? Y minus 8 over 3 is equal to 1 over 12 x minus 1. And because of the way they wanted it, I'm just going to multiply everything here, multiply everything by 12. I'll get 12y minus 32 is equal to x minus 1. And they wanted that in the format x minus 12y here plus 31 equals 0. So they didn't want it in the form y equals mx plus c, but no, that's okay, that's fine. Good, going on at a nice pace here. We've got c done as well. So finally, on to the last part. Use algebraic integration to show that the integral between 3 and 1 of this function works out to be lambda log 10, and then work out what lambda is. So yeah, we just need to be careful at the end of going through this that we have it in the right format when we get there. But part D. Okay, so we're going to integrate between 3 and 1, 16 over 9 lots of 3x minus k dx. So first of all, let's take 16 over 9 out, because it's constant, just in the way. 3 and 1, 1 over 3x minus k dx. Now, again, just as we were talking about with the chain rule, I'd expect most of you to be able to do this. If we've got 1 over ax plus b here, I'd hope most of you would say, well, 1 over x is going to give me log x, so log of our function here, but then I have to do 1 over a divide by the differential of that part there. So I'm hoping that's not too much of a stretch for you all. If it is, go back and do some more revision. So here, this is 16 over 9, and then the integral of what we've got there is a third log 3x minus k. It's a third log 3x minus, remember we know what k is, 7 over 3 here. all between 3 and 1. Now I was going to say it's as simple as now putting these values in. It is, but obviously we do need to get to the stage of lambda log 10. So, okay, well, first of all, let's take the third out as well. Try and make things as easy as possible for ourselves. And then we're going to do log 3x minus 7 over 3 between 3 and 1. So what are we going to get here? So that's 16 over 7. I'm going to get log 9 minus 7 over 3 minus log 3 minus 7 over 3. Okay, now I think you can pretty much put all that into the calculator, but it's 16 over 7. Log 9 minus 7 over 3 minus log 3 minus 7 over 3 actually, 27, actually does work out to be log 10, so I'm not going to spend any more time messing about with the logs there. Always go back and just check, did I answer that in the right format, did I answer that in the right format, but yeah, we've done everything there. Not too bad a question, I don't think, so hopefully that all makes sense to everybody.